cosine of x. And I want to write it as a series expanded at 0. So I'm trying to approximate cosine x near the origin. Okay. And so how do I get a0, a1, and so on? Well, plug in 0 to both sides here. And we get 1 equals a0, right? Because all these other terms out here go to 0 when I plug in x equals 0. Okay, so think about what we're trying to approximate here. We got cosine x, does this. And we're trying to come up with an approximation right here at that point of symmetry. Right? So we're going to start, our function value has to be 1 at that point. What would the slope be right here? Yeah, 0. Right? So how do you see that algorithmically? Take the derivative. Right, so now we're going to differentiate both sides of 1. Right? And if you have a power series that's convergent, you can differentiate it term by term, and you still get a convergent power series. That's one of the facts we'll use. You can integrate it term by term, and you get a convergent series. Right? You can add two convergent series together, and you still get a convergent series, as long as you're in the interval of convergence for both of them. So now I have minus sine x equals a1 plus 2a2x plus 3a3x squared, and so on. So again, plug in at x equals 0. So a1 equals 0. All right, because if I plug in 0, I get on the left side 0. Sine of 0 is 0. On the right side, none of these terms matter, because I plug in x equals 0, they'll go bye-bye. And now I'll just repeat. Every time you take a derivative of both sides, you get a new coefficient. Okay. So do it again. Repeat as needed. Right. That's where all these formulas come from, like there's a formula we'll write down in a second that you're all familiar with, but right. So if I differentiate again, I get minus cosine x equals 2a2 plus 3 times 2 times a3 times x. Right. So right, I had a 3 here from before. Bring down the 2 from differentiating. Plus 4 times 3 times a4 x squared, and so on. Plug in your x equals 0. On the left side, you get minus 1. On the right side, you get 2a2. So a2 equals minus a half. Let's do just one or two more terms. It's getting really tedious, I suppose, right? But just so you can see, there's a factorial that comes up in this expansion, where the factorial comes from. And, I mean, you might already see it, right? So 3 times 2 times 1 is 3 factorial. 4 times 3, when I differentiate again, I'm going to get a 2. So that's 1 times 2 times 3 times 4 is 4 factorial, and so on. So one more time, with feeling. Plug in x equals 0. Right, and you get 0 equals, this is 3 factorial times a3. You can just write an extra 1 in there. Right, this is 4 factorial times 0. So a3 equals 0 over 3 factorial. Of course, that's 0, but I just want to show you where that factorial comes from. If you do it again, you'll get a4 equals 1 over 4 factorial. So what do we have so far? We have cosine x equals 1 plus 0x minus 1/2 x squared plus 1 over 4 factorial x to the 4th